Hello everyone. This video is on section 9.3 titled Solving Quadratic Equations Using the Quadratic Formula. In this video I'm going to be going over a version of the Knewton Alta assignment for section 9.3. Please understand that the questions I see in this version may or may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the types of questions should be similar, so I'm hoping that watching me go through them will help you in some way when you work on them on your own. Alright, so here's the assignment page. Now you will not see the words preview of. You'll just see the title of the assignment, and then you have your mastery bar, showing you how far along you've gotten in the assignment. Then you see the objectives. Looks like there are 3 objectives for this assignment. And then whatever objective appears, there'll be a question below it related to that objective. And at the bottom of each question, there should be a feedback button for which you can send feedback to Knewton. You will not see, you won't see the instructor cheat button. That's for instructors only. But you will see the more instruction button. You click on this and you'll be provided with extra reading material or videos that will hopefully help you when working on certain questions in whatever objective you're working on. Alright, so this first question, the objective is determine the number and type of solutions of a quadratic equation by using what's called the discriminant of the equation. Alright, so before I get into this, I want to talk about this section is about what's called the quadratic formula and using it to solve equations, quadratic equations. I just want to show you that if you remember how to complete the square, remember section 9.2, solving quadratic equations by completing the square. If you remember how to do that, then you'll see very easily where the quadratic formula comes from. And that's actually what I'm going to start off by doing. Alright, I'm going to start by showing you where the quadratic formula comes from and then what the quadratic formula is. Alright, so I got some paper here now. Suppose we're given a quadratic equation in what's called standard form. Say a times x squared plus b times x plus c, where a, b, and c are numbers, real numbers, and the variable is x. You have your quadratic term, your linear term, your constant term, and say that's all on one side with 0 on the other. Right, so as I said, this is typically referred to as the standard form for a quadratic equation. Okay, and of course we also need the value of a. Let's just assume the value of a is not 0, right? Because if it were 0, then this quadratic term wouldn't exist, and it would just be a linear equation. Right? Later on too, we can say that a can be assumed to be positive, because if it were negative, you can just multiply both sides by -1 and make it positive, right? You can also say, let's also assume here that a is a positive number. It doesn't have to be, but this is optional. All right. Now what I'm going to do is I'm going to solve by completing the square. Right, remember what that was from section 9.2. I'm going to be assuming you remember this. So I'm going to solve a general quadratic equation that starts off as ax squared plus bx plus c equals 0. I'm going to solve by that completing the square method that you saw from section 9.2. Alright, so the first thing was to get the quadratic term and the linear term on their own side. So I'm going to subtract whatever c is. So now we have ax squared plus bx and then equals negative c. Right? Subtracting c from both sides. Then I want to get the coefficient of the quadratic term to be 1. So if a is not 1, we need to divide by a. So after dividing by a, I'd have x squared plus b over a times x equals, and then negative c over a. Now comes the completing the square part. We have a quadratic term with a coefficient of 1, and we have a linear term with this coefficient of b over a. Remember what gets added when completing the square. Take half the linear coefficient, which would be b over 2a, and then square it. Now b over 2a, when you square it, you'd have b times b in the numerator, right? B squared, and 2a times 2a, or 4a squared, in the denominator. And don't forget it's an equation. I can't just add this here and not add it over here as well. I add that to the other side, plus b squared over 4a squared. Alright, now the whole reason for this is so that we can get a perfect square trinomial. Right, this x squared plus b over a times x plus b squared over 4a squared. This can be expressed as a binomial to the second power. And that binomial would be x, the variable, plus half of b over a, which was b over 2a. And you can double check. I know there's lots of letters, but it shouldn't be too difficult. Take x plus b over 2a and multiply it by x plus b over 2a again. Do all the foiling, combining like terms. You'll get x squared plus b over ax plus b squared over 4a squared. Alright, then on the other side, I'd have to multiply this first fraction here by 4a over 4a to get a common denominator. And that common denominator will be 4a squared. Right? They both have 4a squared. And then the numerator will be negative 4ac plus b squared. I can switch those terms, say b squared first, put the positive term first, and then minus 4ac. Right, that's the numerator. Then I apply the square root property. Right? I have an expression with a variable squared equal to an expression without that variable, right? No x over here. So then by the square root property, x plus b over 2a is equal to either positive or negative the square root of this expression here. Well, the square root of a fraction, I can break it up to the square root of the numerator. So square root of b squared minus 4ac divided by, and the square root of the denominator, right, the square root of 4a squared would be 2 times a. Right, that's the square root of 4a squared. And again, I can put a here because I'm assuming a is a positive number, right? Remember, typically it would be 2 times the absolute value of a, but let's just assume a is positive because you can always make it positive very easily by multiplying both sides by negative 1. And then finally, get x alone by subtracting b over 2a. And we get finally the solutions of our quadratic equation that started off in standard form. X equals, negative b over 2a, then plus or minus, and then this expression here, right, the square root of b squared minus 4ac divided by 2a. And you might notice that both these terms here have the same denominator of 2a, right? Same denominator of 2a, so those can be put together. And we get what's called the quadratic formula. So the common denominator here is 2a, so that's going to be the denominator of the sum. And the numerators are negative b, and then one with the plus, one with the minus, and then the square root of b squared minus 4 times a times c. All right, and I'm going to put this in a big box here. This is called the quadratic formula. And you see how it came from solving an equation by completing the square? So that tells me something. All right, that tells me that I can solve any equation by either completing the square or the use of this quadratic formula. Right? So you choose which one you want to use more. Now there is one caveat with the quadratic formula. In order to use this, you have to start in standard form. So I'll write that note here. Right. This can only be used when the equation we're starting with is in standard form, or if it's not, if the equation's not in standard form, we just have to put it in standard form, and then we can use this. So this can only be used when equation is in standard form. And please understand this, people tend to misuse the quadratic formula sometimes. It has to be looking like this first. Quadratic term plus linear term plus constant term equals 0. Has to look like this in order to be able to take the coefficients, take the a, b, and c, and plug them into this formula and get my solutions. Right. Now, the question I'm currently on in the assignment talks about something called the discriminant of a quadratic equation. All right. The discriminant is this expression inside the radical symbol of the quadratic formula. This is b squared minus 4ac. All right. So the discriminant of quadratic equation ax squared plus b in standard form, the discriminant of a quadratic equation in standard form, ax squared plus bx plus c equals 0. I'll call D for discriminant. It's again just the expression in the radical of the quadratic formula. It's b squared minus 4ac. Right. And then we have now using this discriminant, we can talk about the number of solutions a quadratic equation will have and what kind of solutions. Will the solution be strictly real numbers? Will they be two real numbers or one real number? Or will they be complex numbers that have an imaginary part? Right? Every number is complex, right? I hope you understand that, right? Real numbers are also considered complex. But in this particular assignment, when they use the word complex, they mean a complex number that has an imaginary number in it, right? So the number I, right, the square root of a negative. So if this discriminant is positive, right, if the discriminant is positive, well, that means you're taking the square root of a positive number. Right? Remember, the b squared minus 4ac, that's under the square root in the quadratic formula. And the square root of a positive number is real. And you'd have two real solutions. Negative b plus the square root of the discriminant over 2a, and negative b minus the square root of the discriminant over 2a. So if this discriminant, this b squared minus 4ac, is positive, the equation has two strictly real number solutions. Two real solutions. Okay. Now, if the discriminant is equal to 0, right, if you take b squared minus 4ac and you get 0, well then in the quadratic formula, when you're finding the solutions to this these standard form equations, this should be the square root of 0, and the square root of 0 is just 0. So negative b plus 0, negative b minus 0, those are the same thing. So your two solutions are repeated. You'd have just the solution negative b over 2a. There would only be one real solution, one repeated real solution. So if the discriminant is equal to 0, the equation has one real solution, right? And that would be the negative b over 2a, right? Because you'd have plus 0 minus 0. That wouldn't do anything. You'd just be left with negative b over 2a as your solution. And then finally, if the discriminant is negative, right, less than 0, right, so if this b squared minus 4ac, right, the discriminant, if the b squared minus 4ac is negative, look what happens. You'd have the square root of a negative number here. And remember, square roots of negative numbers are imaginary. You're going to be rewriting those with that I, right? That square root of negative 1, the imaginary unit I. So then you'll have negative b over 2a plus some imaginary number over 2a. And then negative b over 2a minus some imaginary number over 2a. So you'd have a real number, negative b over 2a, plus or minus some imaginary number as well. So if this is the case, if d is less than 0, the equation has two complex solutions with an imaginary part. The equation has two complex solutions and I should really add on to that, with an imaginary part, because every number is complex. Right. When I say two real, that's two complex solutions as well, but when they use the word complex in this assignment, they mean that there is an imaginary number involved. Right. So two complex solutions with an imaginary part. Okay, so going back to our question, finally. Right. We're asked to use the discriminant to determine the number of solutions to this quadratic equation. And I'll write this out, and you'll note that it is in standard form, right? Everything on one side, 0 on the other. You have a quadratic term plus a linear term plus a constant term equals 0. Okay, so here's the equation we were given. Again, it's in standard form. Everything on one side, 0 on the other. So the value of the coefficients, a, now I know a is not positive, but it doesn't matter, right? It really doesn't matter. As long as it's not 0, right? Because if you have a 0 as a coefficient of the quadratic term, then you don't have a quadratic equation. So remember, little a represents, the coefficient of the quadratic, which is -40. Little b represents the coefficient of the linear term, which is +10. And that little c represents the constant term, which is -1. And don't forget the negatives. Alright, so the discriminant, which I was calling capital D, is this again, right? It's b squared minus 4ac. So just replace these letters. B is 10, so we have 10 squared minus 4 times a, right, so times -40, times c, so times -1. So this is 100, right, that's 10 squared. And then -4 times -40 times -1 would be a negative number. And 4 times 40 times 1 is, 160. So we get the discriminant here is -60. Right? It is a negative number. And that meant that this third part here, the third case, the equation has two complex solutions with an imaginary part, but we're just going to say two complex solutions. Right? So this equation has two complex solutions with an imaginary part. And if you wanted to go further, you could see what those solutions are. Right? We're going to be asked to do this in other examples. What are the solutions to this equation? Now the variable here is m, not x, so I'm going to write m equals. And then don't forget, we have our quadratic formula here. Now again, just replace x with m. Right, here is the quadratic formula. In fact, I'll write it out again. I'll probably write it out several times as we go through these examples. It's the opposite of b plus or minus the square root of the discriminant, right, b squared minus 4ac, and then all of this, right, all of this divided by 2a. So this would be the opposite of b, so -10, then plus or minus the square root of the discriminant. Now we already found the discriminant was -60, right? So that's b squared minus 4ac. And then all this divided by 2 times a, that'd be -80. Right? -80, 2 times, 2 times -40. Okay. Then simplifying these a bit, which you're going to have to do, right? We have -10 plus or minus. Now the square root of -60, remember, is going to be written with that I, right? That's going to be the square root of 60 times I. And the square root of 60 can simplify to 2 times the square root of 15. Right? That's the square root of 4 times the square root of 15. Right? The square root of 60. And then this is all getting divided by -80. All right, and then I actually go and divide each of those terms by -80. So -10 divided by -80, that's positive 1/8. So I get 1/8 plus or minus, and then, 2 root 15 over -80 would be, -1, basically just the square root of 15 over 40 times I. Don't forget the imaginary number. Now, here's a tricky thing. Here's something tricky. Putting this negative here just changes this to minus plus. Right? We have 1/8 minus plus, and then the square root of 15 divided by 40 times I. And having minus plus is the same thing as having plus minus. So this is the same thing as 1/8 plus or minus the square root of 15 over 40 times I, right? But look, two complex numbers, two complex solutions with an imaginary part, right? But yeah, we weren't asked to do that though, right? All we were asked to do is find the discriminant, right, the b squared minus 4ac, and then state what kinds of solutions there were. And like I said, there are two complex solutions, 0 real solutions. All right, I'm going to put 0 in here for the real solutions box because these solutions have imaginary numbers in them, so they're definitely not just real. All right, now submit. Great. So read through the answer explanations, please. Right. After every question, right, there are answer explanations, whether you're right or wrong. And I'd recommend reading these either way. If you're correct, read through them just to make sure you got it right for the right reasons. And if you're, or maybe they went through an alternate method that you might like better, so then you could try that out in future questions. Now, if you got it wrong, definitely read the answer explanations because you want to learn, from your mistakes. You want to see why you were wrong or where you went wrong, and hopefully you can do better in the future. All right, so the next question is on this objective. Solve quadratic equations using the quadratic formula with one or no real solutions. All right. So this is where the discriminant is going to be either 0 or negative. All right. If it has one real solution or no real solutions, right? Remember, one real solution meant the discriminant was 0. No real solutions meant the discriminant was negative. But now we're actually finding the solutions, right? Not just the discriminant. All right, so I'm going to write this equation out the way they gave it to me, and then we'll put it in standard form first, right? You got to put it in that ax squared plus bx plus c equals 0 form first, and then use the quadratic formula. Okay, so here's the equation we were given. Again, notice that it is, pardon me, not in that standard form. So I got to get it to be that way first. And that'll involve, distributing the 5x here to the x minus 2. So we'll have 5x squared, then minus 10x, and then you got the constant term, plus 7 after all that, equals 0. And now this equation is in that form. And once you're in that form, then you can use the quadratic formula. So first I'll identify the a, b, and c. Right? The little a is the quadratic coefficient, that's positive 5. Little b is the linear coefficient, which is negative 10. And c is the constant term, which is positive 7. Right? Then the solutions of this equation, we can jump right, once we have it in this form, we can jump right to the quadratic formula. So x, the variable this time is x equals, and it's the opposite of b, right? So positive 10, actually I'll fill it in, right? The opposite of b, right, negative b, plus or minus the square root, and then inside the square root is the discriminant, right? B squared minus 4ac. So b squared, right, in parentheses here, negative 10 squared, that'd be positive 100, minus 4 times a times c, 4 times 5 times 7. Right? All of that is inside the square root symbol, and then all of this is in the numerator, divided by, and then 2 times a, right, 2 times 5 in the denominator. All right, and now we simplify. All right, so we have x equals, the opposite of negative 10 is positive 10. We have plus or minus. Then the square root of 100 minus 140. All right, we'll simplify that as well, divided by 10. Right. So this is 10 plus or minus the square root of negative 40 all over 10. And the square root of negative 40, remember, going to rewrite that as an imaginary, right? The discriminant is negative here, so I'm going to have two complex solutions with an imaginary part. So 10 plus or minus, and then the square root of negative 40, again, that's going to be imaginary, so I'll have times I after. And then the square root of 40, right, that breaks up to the square root of 4 times the square root of 10, that'd be 2 times the square root of 10 times I. And then each of these terms up top is getting divided by 10. So here are my solutions. 10 divided by 10 is 1 plus or minus, and then 2 square root of 10 divided by 10, 2 goes into 10 5 times, that'd be the square root of 10 divided by 5, and then times, times I. Those are imaginary numbers. So here are the two solutions, right? And they're written in that complex form, the standard form for a complex number. You have a real number 1 plus some imaginary number, square root of 10 over 5 times I, and 1 minus square root of 10 over 5 times I. And those are what I'll enter with, commas separating them. So one solution is, 1 plus the square root of 10, and out of there divided by 5 times I, and then I'll just copy and paste this and replace the plus with a minus. Comma, oops, I need a comma, and then 1 minus square root of 10 over 5 times I. Great. And once again, please, read through the answer explanations. Wonderful. All right, next question. So we're in the same objective, right, where the discriminant is going to be 0 or negative. And we're again asked to solve using the quadratic formula. All right, and use a comma to separate the multiple values if there are multiple values. All right, so this equation is pretty similar to the last one I did. I'm going to distribute the 4q. Right, first I want to put it in standard form, which it's not right now. Right, and that would be 4 times q squared plus 8q. All right, then after the parentheses here you have plus 10 equals 0. Right, now I'm in standard form, but one thing I'm noticing is that all the coefficients are even. All the coefficients are even, so I'm going to divide by 2 on both sides. I'm going to divide both sides by 2 to make the numbers just a little bit smaller. So we have 2q squared plus 4q plus 5 equals 0, right? 0 divided by 2 is still 0. And now I can jump right to the solutions. Right, I am in standard form. Quadratic term plus linear term plus constant term equals 0. And I can jump right to the quadratic formula. All right, q equals, now let's remember this, the opposite of b, and I'll write out what the a, b, and c are over here. A is the quadratic coefficient, which is positive 2. B is positive 4, the linear coefficient, and c is the constant term, positive 5. Right? So we have the opposite of b, so negative 4, plus or minus the square root of the discriminant, which is b squared, right? 4 squared, minus 4 times a times c, and then all of this divided by 2 times a. 2 times 2. Right, so I just fill in the quadratic formula with this a, b, and c. And we start simplifying stuff, right? So this is negative 4 plus or minus. Now this is 16 minus 40. 16 minus 40 would be negative 24. So I have another negative discriminant, right? Both solutions will have an imaginary number. Then all this, right, divided by 2 times 2 is 4. Now the square root of negative 24, we're going to rewrite, right? So this is, numerator is negative 4 plus or minus. Then the square root of negative 24 is imaginary, so it's going to be the square root of 24 times I. And the square root of 24 is 2 times the square root of 6 when you simplify it, right? It's the square root of 4 times the square root of 6. And then I'm just going to take all that, divide by 4, right? Divide each term by 4. Negative 4 divided by 4 is negative 1, plus or minus. And then when I take 2 square root of 6 times I divided by 4, 2 goes into 4 twice. This will be just the square root of 6 divided by 2 times I. And there are the two solutions for this equation. Negative 1 plus square root of 6 over 2 times I, and negative 1 minus half the square root of 6 times I. And those are what I'll enter here. Right. Negative 1 plus the square root of 6, get out of there, divided by 2, move over times I, comma, and then I'll just copy and paste and replace the plus in the middle with a minus. There we go. And those should be good. Wonderful. Okay. Again, please read through the answer explanations. Now they have bigger numbers here because they didn't divide by 2 first. Right? They used 4, 8, and 10. I used 2, 4, and 5. Right? Because I personally just like, if I can make the numbers smaller in the beginning, I'll do that. All right, next question. All right, so we're back to the objective where we're only asked to find the discriminant and then state, does the equation have 2 real solutions, 1 real solution, or 2, complex solutions? And again, when they say complex here, they mean with an imaginary number. All right. Please understand, though, that every number is considered complex. All right, so again, I'll write this out. We'll find the discriminant and state what kinds of solutions this equation will have. All right, so the equation is already in this standard form, right, the way I want it. The value of a here is negative 6. The value of b is negative 10. And the value of c is negative 3. Now, if you don't like I said before, if you don't like having a negative lead coefficient, which I usually don't, you can multiply both sides by negative 1 and make it positive 6, positive 10, positive 3. And either way, you'll end up with the same discriminant. Right? So the discriminant, remember, is b squared minus 4ac. And this is that expression underneath the square root symbol in the quadratic formula. So that's, negative 10 squared minus 4 times a, so it's 4 times negative 6 times c, right, times negative 3. So this is 100, right? Negative 10 to the second would be positive 100. And then a negative times a negative times a negative will be negative again. And 4 times 6 times 3, that's 24 times 3 be 72. Right, or 12 times 6, 72, either way. So we're getting here a positive discriminant. Right? The discriminant is 28. This is a positive number, meaning that the equation, you'll be taking the square root of a positive number in the quadratic formula, which will be a real number, and you'll have two real solutions. The equation has two real solutions. Now, technically, two real solutions are also two complex solutions, but again, their use of the word complex here means that it has an imaginary number in it. So we have two real solutions and 0 of these complex solutions with an imaginary part. At least I think that's how they're doing it. Okay, good. All right. And then again, please read through your answer explanations. Okay, and now we're solving quadratic equations using the quadratic formula with two real solutions. So they're telling us that it's going to have two real solutions. That means the discriminant, right, b squared minus 4ac, is going to be positive. All right, so once again, I'll write this out and we'll do it on some paper. All right, so this equation is not in standard form. So I would have to add 1/5, right? So we have 1/2 u squared plus 3/4 u, and then plus 1/5 equals 0. Now it's in standard form. Everything on one side, 0 on the other. Quadratic term plus linear term plus constant equals 0. And I could, if I wanted, jump to the quadratic formula right now if I wanted to. But most people I have found don't like working with fractions too much. So what I'm going to do is multiply both sides by 20, which is the LCD, just to clear all the fractions away and make it a little nicer looking, have the numbers be a little nicer to work with. It's easier to work with integers than it is with fractions for most people. So 20 times 1/2 is 10, so this is 10u squared plus, and then 3/4 times 20 would be 15, right, plus 15u, and then 1/5 of 20 is 4, right, so plus 4 equals 0, and this is also valid. These are the same equation, right, just multiply both sides by 20, right? They'll have the same solutions, they're equivalent equations. Alright, now I'm going to use this equation in standard form and find its solutions by, jumping into the quadratic formula, right? So the value of a here is 10. The value of b is 15. And the value of c is positive 4. And let's just now jump into the solutions. U equals, right, the variable's u this time, negative b, right, the opposite of b, so negative 15 plus or minus the square root of b squared, right, so 15 squared minus 4 times a times c. Right. And then all of this divided by 2 times a. Okay, now we simplify. So we have negative 15 plus or minus the square root. Now 15 squared is 225, and then 4 times 10 times 4 is just 160. 225 minus 160 would be 65. All right, 225 minus 160 it would be positive 65, right? So we have real numbers here, two real solutions. The discriminant is positive. And all this, right, divided by 20. All right, and then just like all the others, I'm going to divide each of the terms up top by 20. We have, negative 15/20 is 3/4. Then plus or minus the square root of 65 divided by 20, right? The square root of 65 doesn't simplify any further, right? This is 5 times 13. And there we go. Here are the two solutions. Now both are real, right? There's no imaginary in this. We have negative 3/4 plus 1/20 of the square root of 65, and negative 3/4 minus 1/20 of the square root of 65. And that's it. Those are what I'll enter. So negative 3/4 plus the square root of 65, then that divided by 20, and then a comma, and then I'm just going to copy and paste it and replace the plus with a minus. And negative 3/4 minus the square root of 65 over 20. Great. Okay, and then again, please, read through the answer explanations. All right, moving on. All right, so again, I have this objective where they're telling me that the equation's going to have two real solutions. All right, and it's very similar to the last one with some fractions here. So I'm going to write this out and work on it on some paper. All right, so right away I'm seeing, it's not in standard form. Just need to add 1/3. So we'd have 1/4 q squared plus 3/4 times q, then plus 1/3 equals 0. All right, now it's in standard form, and you could, if you wanted, have A be 1/4, B be 3/4, and C be 1/3, and then use the quadratic formula and do all sorts of simplifying, but you're going to be dealing with a lot of fractions, which again I find most people don't like. So if we want, we can create an equivalent equation where the coefficients are integers instead by multiplying through by the LCD, which would be 12 here, right? So I'm going to multiply both sides by 12. Now 1/4 of 12 is 3, so that's 3q squared, plus 3/4 of 12 is 9, right, so plus 9q, plus, and then 1/3 of 12 is 4. All right, so I'm going to work with this one now, right? 3q squared plus 9q plus 4. The value of A here is 3, the value of B is 9, the value of C is 4. Okay, and jump right to the solutions. We're in standard form, we can jump right to the quadratic formula for the solutions of this equation. Q equals, the opposite of B, so negative 9, plus or minus the square root of the discriminant, right, that B squared, 9 squared, minus 4 times A times C, 4 times 3 times 4. And then all this divided by 2A, right, divided by 2 times 3. Okay, so we have in the numerator negative 9 plus or minus the square root. Now 9 squared is 81. Then 4 times 3 is 12. Times 4 would be 48. 81 minus 48 would be 33. Positive 33. So again, the discriminant, right, that b squared minus 4ac is positive. So I'm going to end up here with two real number solutions, right? No imaginaries. then all this divided by 6, right? 2 times 3. And then if I divide each term up top there by 6, we're getting the following solutions. Q equals, negative 9 divided by 6, that's negative 3 halves when you reduce it. Then we have plus or minus, and then square root of 33 doesn't simplify, that's 3 times 11. So we just have the square root of 33, divided by 6. There you go. All right, here are our two solutions, and again, I'll write each of these separated by a comma. All right, so one solution was negative 3 halves plus the square root of 33, and that square root of 33 is being divided by 6. All right, then a comma. I'm just going to copy and paste this and change the plus to a minus. Negative 3 halves minus the square root of 33 divided by 6. And I submitted. And it sure is taking its sweet time here. Okay, here it is, finally. Hooray, I did it. And again, please read through your answer explanations. Next question. So still the same objective. We're going to have another very similar question with all these fractions in it. So I'll write this out and we'll work on it. All right. So again, first thing I want to do is put this in standard form. I'm going to add 1/6. So we have 2/3 w squared, pardon me, plus 3/4 w plus 1/6 equals 0. All right, and then as I've been saying, once you have it in standard form, you can use, A is 2/3, B is 3/4, C is 1/6, and use the quadratic formula. But the simplifying might be a little annoying because of all the fractions. So what I'm going to do is I'm going to multiply by, I'll just put the little time symbol, the LCD, which is 12. So I'll multiply everything by 12 on both sides. Now 2/3 times 12 is 8, so that's 8w squared, plus 3/4 times 12 is 9, so it's 9w, and then 1/6 of 12 is 2, right, plus 2 equals 0. All right, now I have a nicer looking equation because the coefficients are integers, and it's in standard form, right? So I can jump to the quadratic formula. The value of A is 8, the value of B is 9, and the value of C is 2. All right, so we jump right to the solutions. W equals negative B, so negative 9, plus or minus the square root of the discriminant. Right, that b squared minus 4ac, so 9 squared minus 4 times 8 times 2. And then all this divided by 2 times a, so 2 times 8. And then we start simplifying. The numerator is negative 9 plus or minus the square root of, 9 squared is 81. 4 times 8 times 2 is 64. And 81 minus 64 is 17. 64 plus 17 would be 81. And another positive discriminant, right? B squared minus 4ac is positive, meaning that I'm going to have two real number solutions, right? No imaginaries here. And then we have divided by 16. All right. Now, dividing each term up top by 16, we have negative 9/16, which doesn't reduce, plus or minus, the square root of 17/16, which also doesn't reduce. So if you want, because nothing reduced and whatnot, you can just leave everything over 16. Let me show you what I mean. All right, here are our solutions, or the two real number solutions. But let me show you what I mean when I can enter these. Since these have the same denominator, I can keep them combined. One solution is, in parentheses, I've got -9 plus the square root of 17, and then all that divided by 16, right? And then I'll just copy and paste that answer and replace the plus with a minus, right? You can do that as well. If they both have the same denominator, you can keep them together. And then replace that with a minus here. And that should be valid. Alright, I think it takes a while to check these for some reason. Either my internet connection's slow today, or because there are so many different ways to type in the same answers. Alright, and again, please read through your answer explanations. Alright, so it looks like we have one final question from that same objective, and it looks very similar to all the others with these fractions. So once again, got all these you know what, I'm going to do this to start. I'm just going to multiply everything by 12 just to get rid of the fractions right now. So that's 4d squared plus 6d equals -1. Alright, multiplying everything by 12 just to get rid of all those denominators, and then I'll put it in standard form by adding 1. So we have 4d squared plus 6d plus 1 equals 0, and now the equation's in standard form. So I can use the quadratic formula to state the solutions. The value of a here is +4, the value of b is +6, and the value of c is +1. Alright, so the solutions are, d equals the opposite of b, which would be -6, plus or minus the square root of the discriminant, b squared minus 4ac, right? 6 squared minus 4 times 1, and all this divided by 2 times a, right? 2 times 4. So that's -6 plus or minus the square root of 20, right? 36 minus 16, all divided by 8. And the square root of 20 can simplify, right? That's 2 times the square root of 5. Right? Square root of 4 times square root of 5, and then all this divided by 8. And then dividing each of these by 8 gives us the following. Right? -6 divided by 8 reduces to -3/4. Then plus or minus, and then the 2 goes into 8 4 times. So you'd have the square root of 5 divided by 4. And there you go. And again, since these have the same denominator, you could make it -3 plus the square root of 5 all over 4, and -3 minus the square root of 5 all over 4, and those are the same numbers. All right, but I'll just enter these the way I have them here. So one solution is -3/4 plus the square root of 5, then that divided by 4, not 44, and then comma, and then I'll just copy and paste this and replace the plus with a minus. And -3/4 minus the square root of 5/4, square root of 5 divided by 4. And those are two real solutions, right? No imaginaries, and those should be good. Just give it a second here. Excellent. Alright, so it looks like that objective's done, where you're going to have two real solutions. Moving on. Going back to the objective where we're asked to just find the discriminant and state what kinds of solutions. Will it be two real solutions, one real solution, or two complex solutions, right, with imaginary numbers involved? Alright, so once again, as with the other questions we've seen from this objective, the equation's already in standard form. So I just need to, now the problem is here, the variable's little a, but that shouldn't be a big deal, right? Just be careful, right? The discriminant, remember the discriminant, which I've been calling capital D, it's, little b squared, which is, the linear coefficient squared, so 90 squared minus 4 times, now again, little a might confuse you with this little a here, but remember the little a in the discriminant formula and the quadratic formula is the coefficient of the quadratic term. So negative 4 times negative 81, right, negative 81, sorry, and then times little c, which is the constant term, which is negative 25. Right. So 90 squared is 8100, and then a negative times a negative times a negative is a negative, so minus. And 4 times 25 is 100, so this is 8100 again. And look at this, the discriminant is 0. Remember what happens, it's been since earlier on in the video, but when the discriminant is 0, you're taking the square root of 0 in the quadratic formula, you only end up with one real solution, whatever negative b over 2a is. So this tells me that the equation has exactly one real solution. And that's it. Right? The only real solution would be negative 90 over 2 times negative 81, whatever that is. Right? Simplified. But it's just negative b over 2a when the discriminant is 0. But all we're asked to enter here is that there's one real solution and no solutions with imaginaries, right? These complex solutions, the way they're using the word complex here. And that's it. Right. So pretty simple. Alright, so moving on. Alright, looks like we got just one more question here where, again, we're given an equation that looks like it's in standard form already and asked to find the discriminant and then state how many solutions and what kinds of solutions this equation will have. Right, so I'm just going to go back to this page here and just write it underneath and just add this. They gave us this equation, 25 times a squared plus 30 times a plus 9 equals 0. Alright. Then you might even say, hey, I know how to factor this, and there's only one solution here, we'll see in a second, but let's do the discriminant, right? It's in standard form. So the discriminant is b squared minus 4ac. 30 squared minus 4 times the quadratic coefficient times the constant. And this is 900 minus 900, which is again 0. So just like the earlier, just like the most recent example, the discriminant is 0, meaning that this equation only has one solution, one real solution. That'd be whatever negative b over 2a is, so negative 30 over 50. The only solution to this equation is negative 3/5. And you can check that with the quadratic formula and whatnot. But so just like the last example, there's only one real solution, and there are no solutions with imaginary numbers. Right? 0 complex solutions. Great. All right, so that objective's done. Wonderful. All right, so the last objectives, the last questions are on the objective where you're going to have either no real solution or one real solution. So remember, when there's no real solution, that meant the discriminant was negative. B squared minus 4ac was negative. And one real solution you just saw when the discriminant is 0. Alright, so let's look at this equation. Alright, so this equation clearly not in standard form yet. I have to distribute the d here. So we'd have 7 times d squared minus 6 times d. Then you have plus 4 equals 0. Now I have the equation in standard form. And the coefficients are 7 for the quadratic term, negative 6 for the linear term, and positive 4 is the constant. And once I'm in standard form, I can jump right to what the solutions are, right, using the quadratic formula. So d equals, remember, it's the opposite of b. Right? So b is negative 6, that means there's positive 6 up there, right? The opposite of b. Plus or minus the square root of b squared, right, negative 6 squared, minus 4ac, so minus 4 times 7 times 4, and all of this divided by 2 times 7, right, divided by 2 times a. So we have 6 plus or minus the square root of, now this is 36, minus, and then we got 16 times 7, be 102. Right, 70 plus 42, 102. No, 112. 112. 70 plus 42 would be 112. So yeah, so 36 minus 112. What, 76? Yeah, 36 and 76 would make 112. So it's negative 76. Right, 36 minus 112. Let me just double check that. Yeah. All right. And then divided by 2 times 7, 14. Now remember, the square root of negative 76, we're going to rewrite as the square root of 76 times I, right, as an imaginary number. So there will be no real solutions here. And the square root of 76, that's the square root of 4 times the square root of 19. So that's 2 root 19. Right? So we have here 6 plus or minus 2 times the square root of 19 times I all over 14, and then I split it up, divide each of these terms in the numerator by 14. 6 divided by 14, that reduces to 3/7 plus or minus, and then when I do 2 times the square root of 19 I times I over 14, the 2 goes into 14 7 times. So that's left with the square root of 19 divided by 7, and then times I. And here are the two complex solutions with an imaginary number. And let me enter those. All right, so again, we separate them with commas, right? So one of them is 3/7 plus the square root of 19, then divided by 7, and then that thing times I, and then a comma, and then I'll just copy and paste this and change the plus to a minus. Okay, 3/7 minus the square root of 19 divided by 7 times I. Wonderful. All right, I probably got just one more of those, I think. If you're doing everything correctly, right, most objectives will only have 4 questions to do. That is if you're doing stuff right. If you get things wrong, then they'll throw more questions at you. All right, so once again, another quadratic equation, which is going to have one real solution or no real solutions, right? So I either have a 0 discriminant or a negative discriminant. Alright, so if I'm going to be using the quadratic formula, got to get it in standard form first, right? So I got 3y squared plus y, then plus 1/12 equals 0. Right? So now it's in standard form. And once again, if you want to, you could use the quadratic formula with a is 3, b is 1, and c is 1/12. And just based on what I know about the quadratic formula, I'll tell you right now, it would be nice to do it here. Watch this, right? So a is 3, b is 1, and c is 1/12. Watch what happens here. And this isn't always going to happen, right? Most of the time I would multiply everything by 12 to get nice integers, but we can just jump to the solutions right now and say y equals, negative b, so negative 1 plus or minus the square root of b squared, right? 1 squared is just 1. Watch this, minus 4 times a times c. 4 times 3 times 1/12, that's 12 times 1/12, that's just 1. And then all this divided by 2 times a, 2 times 3. And I get negative 1/6. Because look, this expression here, this is 1 minus 1, this is 0. Right? The discriminant 0. 4 thirds times 12 is just 4 thirds is 12 times 1/12 is just 1. You get 1 minus 1, you get 0. So that's square root of 0, that's gone. All I'm left with then is negative b over 2a, negative 1/6. There's only one real solution to this equation. Right. Now again, the reason I kept it this way is because I noticed that a times c was going to be canceling with the denominator 4a, sorry, I noticed that 4 times a was going to cancel with the denominator of c. That doesn't always happen. Now normally, right, I would do this, right, I would times everything by 12 to get rid of the fraction, and we'd have 36y squared plus 12y plus 1 equals 0. And then if I use the quadratic formula here, we'd have y equals, negative 12 plus or minus the square root of 144 minus 144. All right, because it'd be 4 times 36, which is 144 times 1. And then divided by, 2 times 36. And this is 0, right, so that's gone. And then, you get negative 12 over 72, which is indeed negative 1/6. So, I mean, either way you do it, you end up with negative 1/6, right? You can keep the fractions if you want or not. And that's it. So there's no commas here, right? There's no multiple solutions. There's only the one real solution of negative 1/6 because the discriminant was 0. And that's it. Great. So I hope you got your quadratic form. I would highly recommend memorizing this just to make things faster for you. But if you don't memorize this, you can always just solve by completing the square method, right, from section 9.2. If you remember how to solve a quadratic equation by completing the square, you don't need the quadratic formula. They both end up with the same results. They both end up giving you the same solutions. So it's up to you what you like better. All right, and that should be it for this version of this assignment. And as I said at the top of the video, the questions I saw here, right, aren't necessarily going to be the questions you see when you work on the assignment on your own. But the objectives are the same. The types of questions are similar. So I am hoping that watching me go over these, 12 questions here helps you in some way when you're working on the assignment by yourself or on your own. All right, and thank you very much for watching.